Hi guys, and finally Mindset Learn Extra is back. It's Monday and it's time for grade 10 maths. Tonight's show is brought to you by Liberty. You guys rock. Last week we covered linear inequalities with Dina, and tonight we're going through trigonometry and triangles with Liesel. Hi Liesel.
How are you doing, guys? We've got a lovely, exciting lesson lined up. We're going to have a look at the basic trigonometric ratios and also how to use them to solve more practical types of problems.
Okay guys, so tonight's show will start off on a lesson on trigonometry and triangles. Then after the break we'll be working through an example or two. Then lastly we'll be tackling your questions in the last 15 minutes of the show. Please don't forget to talk to us on Facebook. That's facebook.com/learnextra. Also chat to us on Twitter. That's @learnextra. I also have a Casio calculator to give away today. So guys, get those comments in, get those questions in, and we will be announcing the winner on the page tomorrow. Another thing we will be doing today is posting up previous week's winners, just so we can see that we haven't missed anyone out, because I think there are a few of you that haven't sent through your email addresses yet. But we'll do that after the break. So what we're going to do now, take a little mini break, and you guys know the drill. We'll be back in 5 minutes, and we'll be back with Liesel. See you then. Hi guys, and welcome back. This is grade 10 Learn Extra Live Maths, and I hope you're all tuning in. Tato says that she's ready for the lesson today, and she says hello friends. So if you guys are out there and you guys are watching in study groups or with friends, let us know on the page, even if it's just to pop in and say hello. And don't forget, we will be answering your questions in the last 15 minutes of the show. But I'm Indiana, and I'll be chatting to you on our Facebook page, facebook.com/learnextra, also on Twitter @learnextra. So get chatting to me guys. And we've got some exciting things happening in today's shows. So if you are in grade 11 or in grade 12 and you will be watching the grade 11 and 10 shows, keep watching the page because we've got some exciting news to share with you. Now, I think what we're going to do is we're going to go over to Liesel and get this lesson started. Over to you, Liesel.
Hello, guys. Right, so today's lesson is all about trigonometry. Trigonometry, we start in grade 10, then we build a little bit on it in grade 11, and finally we finish off the syllabus in grade 12. So it is really, really important that the basics which we learn in grade 10, we know them well and we understand them well. Otherwise, we're looking at a bit of a rocky road ahead. So I'm going to start with the 3 trigonometric ratios that we have to know. So the first one is sine, even though we write it as sin, we say sine, and sine of any particular angle, we'll call the angle theta, is equal to y over r. We'll talk a little bit just now about what y means and what r means. Then cos of theta, or cosine, is equal to x over r. And finally, tan of a particular angle is y over x. Right, now there's many rhymes out there to help you remember these things. I'm first just going to talk about what y, x, and r are in terms of a triangle. Right, so let's have a look at our right-angled triangle over here. Now, when we are doing trigonometry, we always position ourselves at a particular angle. So let's say I am standing over here at this angle. We'll call the triangle ABC. Okay. The first thing that we need to know is that the side across from the 90-degree angle, so that would be the longest side, is called the hypotenuse, and the hypotenuse is also r. Okay, so this side, and it doesn't change, across from the 90-degree angle, have a look there, it's directly across from the 90-degree angle. That is the hypotenuse, which we also call r. Right. So next to all of the r's here, we can write hypotenuse and hypotenuse. Right. Then, if I am standing over here in this position that I'm indicating to you over here, I've now got to look at the position of the other two sides apart from the hypotenuse relative to where I'm standing. Now, if I'm standing over here, this side over here, AB, is the side opposite to me. So opposite is Y. So I'm going to write next to all the Y's, opposite and opposite. Okay? So if I'm standing over here at C, this side AB over here is opposite to me. Then I need to also talk about X. What does X stand for? X stands for the adjacent side. Now, adjacent means next to me. Now, if I'm standing over here, this side over here, BC, is adjacent to me. So next to the X's, I'm going to write adjacent. Now, we do need to be quite careful though. Have a look at this triangle over here. I'm going to say that this side is 5 centimeters long. This side is 4 centimeters long. This side is 3 centimeters long. The angle over there, angle A, is 90 degrees. Right. So, remember now, sine, cos, and tan are ratios of the lengths of the sides. Now, if I say, looking at this triangle, find for me the sine of angle B. This is now very, very important. What you will do is you will mentally place yourself, sorry, not of angle B, I meant to say angle C. Of course, B is our 90-degree angle. So let's say the sine of angle C. If I want the sine of angle C, I need to place myself mentally. Obviously, you don't have to draw a picture, but I need to place myself over here at C. Then I say to myself, right, sine is y over r, which is opposite over hypotenuse. Now, y over r. Now, the hypotenuse in this triangle remains unchanged, right? The hypotenuse in this triangle will always be the side across from the 90-degree angle, so the hypotenuse is 5. Y, or opposite, in this case, if I'm standing over here in the position C, I can say that the opposite side is 4. So the ratio, the sine of C, would be 4 over 5. But look now, if I ask you to calculate the sine of A, that is a different story, because now you need to place yourself over here at angle A, and whilst the hypotenuse remains 5 centimeters, the opposite side to angle A now switches around and it's 3 centimeters. So remember, you cannot just decide, oh, this is Y, this is X. Y and X depend on your position. So Y and X depends on where you are standing. Right. Now, you might ask me, well, I don't know so much. What's the point? What can I use this for? Well, let's have a look at an example. Now, trigonometry is probably in mathematics the branch of mathematics that is most practical. If you think of land surveyors, people that build large skyscrapers and such, they need to use trigonometric calculations all the time. Okay, so I've got a triangle ABC, right? And I know that this side is 3 centimeters and this side is 4 centimeters, and I am asked to calculate the size of angle C. Now, what I'm going to do is I'm going to place myself over there at C. And I'm going to say, right, let me have a look at the information that I have. If I am standing in position C, the side AB, which is 3 centimeters, is opposite to me, and the side BC, which is 4 centimeters, is adjacent to me. And then I say, right, which trig ratio uses opposite and adjacent? See how important it is that you guys know your basics. Opposite over adjacent is tan, that's y over x, and then I will say, right, the tan of angle C is equal to y over x, which is 3 over 4. Okay, fine. So the ratio of the sides to each other is 3 over 4. I can now use that ratio to calculate the size of angle C. Let's get out our calculators. Now, if you have the ratio and you are looking for the angle, you are going to be using the shift function of your calculator. So I'm going to say shift tan, and over there I'm going to say 3 over 4. Let's close the bracket. And the calculator is going to give me the size of the angle, which is 36,869 degrees. So remember now, if you have the ratio and you are looking for the angle, you will be using the shift function. If, however, you knew that this angle was 36,8 degrees, you would have gone about it in another way. If you wanted to get the ratio, you would have said plane tan 36,86 degrees, and it would have given you the ratio. You guys can see it's 0,749, which is close to 0,75. I didn't include all of the decimals. Right, so the most important things that we need to know when we're dealing with triangles: sine y over r, which is opposite over hypotenuse; cos x over r, adjacent over hypotenuse; tan y over x, which is opposite over adjacent. We also need to remember that r does not change position. The hypotenuse remains constant. It is always the side which is directly across from the 90-degree angle. The other two, y and x, can swap around depending on where you are. So that is why, if you're having difficulty at this point, if they're talking about angle C, draw yourself a little man at angle C so that you know that that is the vantage point that you're looking for. So once you know these things, you can now use these skills to calculate sides in triangles, to calculate missing angles in triangles. Another important thing that I think we mustn't forget is, because we are dealing with 90-degree triangles, and this is very important, in grade 10 we will only be dealing with 90-degree triangles, we can also use the theorem of Pythagoras. Remember, x squared plus y squared equal to r squared. Right, so that was quite a lot of information. The main things, hopefully you've jotted them down. Let's now, after the break, we're going to have a look at how we can apply everything that I've been telling you into some really nice practical questions. Is everybody looking forward to this, Indiana?
Yeah, I hope so. We've got quite a few people chatting on the page already. Timbela says that your show really helps us. Crying, don't cry. It's our job to help you guys. So guys, spread the word, spread the message. Tell all your friends about Mindset Learn and how we can help them. We do also have a teacher page, which is quite exciting, guys. So Learn Extra Teacher Talk. I will be putting the page's URL on the Facebook page. You can tell all your teachers about it. What we're going to do is we're going to go to a short break, and when we get back, we're going to be learning more, Learning Extra. See you then. Hi guys, and welcome back to Learn Extra Live, Maths Grade 10. Hope you're all enjoying the session so far. We're talking about trigonometry and triangles. Hey Liesel, so guys, if there is anything that you're not understanding, please get those questions on our page. We will be answering them in the last 15 minutes of the show. Our page is www.facebook.com/learnextra. Get chatting to us, and most of all, get chatting to each other. Help each other out. Before we start, I just think it's fantastic that Tumelo said that she's with Koketso and Karabo and they're doing a study group. Guys, I think that is amazing. If you guys do have a study group going, please let us know on the page. And before we go over to Liesel, I just want to say a big up to Liberty for making this awesome show possible, and keep your eyes peeled to the page. We've got some exciting news happening later on today. So Liesel, without further ado, take it away with your awesome lesson.
Right guys, let's have a look at our first question. This is not a very difficult one. We haven't put a big story around it just yet. We're keeping it sweet and simple for the start. So the question says, refer to the figure, and it talks about triangle DEF. So here's triangle DEF. It's drawn for us over there. They tell us that F is 90 degrees. That of course is essential if we're working with our trigonometric ratios. And then the question says, give the correct ratio or the corresponding trig function for each of the following. Right, fine. It starts off then with the first question wanting from us the sine of E. Now remember, we spoke about that just now. Sine is y over r, which is opposite over hypotenuse. Remember, the hypotenuse is always the side across from the 90-degree angle, so that one doesn't change. However, y and x depend entirely on where you place yourself. Now, this particular question is asking for the sine of E. So very important, and guys, you might think it's juvenile, but you can really do it for the moment. I'm going to draw myself a pink man over there. I am standing over there at E. Right, so the sine of E is equal to y over r, and we need to remember what y and r stand for. Y is opposite, and r is the hypotenuse. Okay, so if I'm placed over here at E, the side opposite me, remember guys, if you're talking about your neighbor opposite or across the road, it means not next to, across. So the side opposite to me is little e. In this case, they didn't tell us how many centimeters, they just put the little e, so that's fine. I'm going to say that's little e. Divided by, now remember, r stands for the hypotenuse. The hypotenuse remains unchanged throughout. It is always the side across from the 90-degree angle. So, therefore, in this case, that will be f. So that's E over f. Quite straightforward, nothing too much to it. What did I do? I remembered what sine was, y over r. I remembered what y and r stand for, opposite and hypotenuse. And then I remembered to place myself in the correct position. Not too much to it. Right, let's move on to the next part of the question. We'll just rub out all of these guys. The next question asks me for tan of angle D. So, fine, now I'm going to move my trig man. Oh, let's make it a trig woman. Right, so I'm moving my trig woman across to angle D. And I say to myself, right, this is my vantage point. This is from where I'm going to decide what's happening. Cool. So then I need to remember, what is tan? Tan is y over x. And what do y and x stand for? Y is the opposite, and x is the adjacent side. So very important that you move yourself across to angle D now. Fine, so I'm standing over here. The side across from me is little d, and the side adjacent to me is little e. So the answer to this question, tan of D, is small d over small e. Right. So at this point, what you guys can see about this question is there's nothing difficult. We're not working out angles. All we want to do is to see whether you know what the different trig ratios mean. Okay. Now finally, if we read the question again, it said, give the correct ratio or the corresponding trig function for each of the following. Now, in the first two questions, we had sine of E, then we had tan of D, and we gave them the ratio. Now, in the third question, question C, the ratio is given to us, and we've got to say sine, cos, or tan, and of which angle. So let's check that out. So they say little d over little f. Fine. I'm going to start off by placing myself at angle D again. And I'm going to say relative to there, little d is the side opposite. In other words, it's y, and little f is the side across from the 90-degree angle, so it's the hypotenuse. So if I'm standing at D, but only if I'm standing at D, y over r is sine. So I'm going to say this could be sine of angle D. But the interesting thing is this is not the only thing that it could be. If I then move myself over to angle E over here, and I now place myself over here, now D is adjacent to me and F is still the hypotenuse, and adjacent x over r, the hypotenuse, is cos. So that could be either the sine of D or the cos of E. Okay, so if I was standing over here, it's a sine function. If I'm standing over here, it's cos. So very important, where do I place myself? Rightio, let's carry on with the question. Now they say to us, if it is further given that D is equal to 3 units, E is 4 and F is 5, use the information to calculate size D, the size of angle D, rounded off to 1 decimal digit. So let us clean up our picture yet again. And I'm just going to take this information and I'm going to put it onto my picture. Little d is 3, F is 5, and E is 4. Okay, so they give us the lengths of all of the sides. We don't actually need all of the sides, but that's all good. So we are asked to use the information to calculate the size of angle D. So very important, place yourself over here at angle D. Now I'm going to show you guys that there's more than one way that I can calculate it. If I'm standing here at D, what I could do is I could say, if I use the 3 and the 5, okay, the 3 and the 5, from D, 3 is opposite and 5 is hypotenuse. So I could do this. I could say opposite and hypotenuse is sine, so I could say sine D is y over r, opposite over hypotenuse, 3 over 5. But because I'm given all the sides, I could also do a cos D. I could say cos of angle D is adjacent over hypotenuse, so that's 4 over 5. And regardless of which one of these two trig ratios I'm using, I will get the same answer, which is quite cool. So let's bring up our calculator. We're going to go shift sine of 3 over 5. Remember, if we've got the ratio, we use the inverse. Right, so let's clear that. Shift, sine, 3 over 5, 3 over 5, let's close the bracket, and that's going to give us the angle. And the angle is 36,869. The question said round it off to 1 decimal digit, so I'm going to say 36,9. Okay, but now let me show you something quickly. If I were now to have used the cos is 4 over 5, sorry it's obscured there, I'm going to go shift cos of 4 over 5, close my bracket, and what do you know? 36,9 rounded off to 1 decimal digit. So the ratios, even though I use different ratios, I will get the same angle. Right guys, so that was a relatively simple question, just testing whether you know the difference between sine, cos and tan, and whether you can work your way around the calculator. Now we're going to take a bit of a break. Indiana, I'm interested to know whether everybody is following, because I'm starting to get ready to move on to things that are maybe a little bit more interesting. What's happening out there?
Okay, guys, we don't have any questions as of yet. So if you do have any questions regarding what we've just spoken about for Liesl, please get them in on our page during the break. I have very exciting news that I'm going to be announcing on the page shortly that you can go to and have a look at. It's facebook.com/learnextra. Today, grade 10s, I know you're watching now, but grade 11s, there will be a new presenter starting in the grade 11 show. And I know you're all going to want to see who it is and what they're all about. And don't worry, they're fantastic. What we're going to do is we're going to take a little break and we'll be back with you shortly. See you now. Hi guys, and welcome back to Learn Extra Live Maths Grade 10. I hope you're all having lots and lots of fun. I know there's a whole bunch of you actually on the page. Priska, Mbuso, Lewis, Spakazi, Treasure. The page is going wild. So guys, if you do have any questions, we are answering them in the last 15 minutes of the show. We didn't have anything for Liesl now for after the break, so I'm just going to assume that you guys all understand. If you don't, keep those questions coming. Question session is in the last 15 minutes. So, Liesl, let's take it away.
Right, before we go on to the next question, I just quickly want to clear something up. Somebody put this on the page and said they were getting confused by my man. Now, guys, the man is not there to confuse you. The man is there to help you. All that I'm saying is, in a triangle ABC, and it could be DEF, okay? The side across from the 90-degree angle is always the hypotenuse. That cannot change. However, if you are placing yourself over here at C, then the side opposite to you, in other words Y, will be AB, and the side adjacent to you, in other words X, will be BC. If you now move yourself to position A, the side that was adjacent before, BC, now becomes opposite. And the side that was opposite before now becomes adjacent. Which is why that vantage point where you're standing is so important. Obviously, guys, you do not have to draw a man. Right, so let's get on with our next question. Not a very difficult question either, I think. I've kept the hardest one for last. Okay, so the length of the diagonal of a rectangular hall is 58 meters. Now let's redraw that. Okay, take the red. Oh no, Indiana, that is very skewed. Let's do that. Okay. Right, so here's our rectangular hall. I'm just going to draw the picture a little bit bigger than it is before. Fine. So the hall is rectangular and the length, the longest side, is 58 meters. So far, so good. Oh, sorry, no, guys, so far not so good. I'm I'm misreading my own question, which is something which you guys actually often do. The question says the length of the diagonal of a rectangular hall is 58 meters. Now, what is a diagonal? A diagonal is a line that goes from one corner to the next, across from it. So there's the diagonal. That would be a diagonal, right? So that is 58 meters. Let's put that on here. Now, guys, please bear in mind the fact that this is a rectangle means obviously that all of the vertices are 90 degrees. Right. Then let's have a look at the rest of the information. The angle between the diagonal and the length is 20 degrees. So what they're saying is this angle over here between the length of the hall and the diagonal is 20 degrees. Right. So we've got all our information there. The question to us is to calculate both the width and the length of the hall. Right. Now, hopefully you guys can see that I don't actually need to work on the entire rectangle. And if it makes it simpler for you, you can just draw this triangle which you will actually be using. So let's do that. So the triangle looks like this. We've got the length, we've got the width, we've got the 90-degree angle, we've got the 20-degree angle over here, and we know that the length of the diagonal is 58 meters. Right, so feel free to simplify things for yourself if you want to. Right, now remember when you're doing trigonometry that all of the other things that you've learned in maths are still applicable. So if you wanted for some reason to work out the size of this angle, that would be 70 degrees because you'll be using angles of a triangle. Now usually what I do is I take the angle that they give me and I use that as my reference point. That is where I'm going to be working from, and if I'm going to be drawing a man, that's where the man is going to stand. So let's do that. I'm going to start by calculating the width of the hall, right? So this is the width of the hall. Okay, that's the shorter side, and I'm putting a question mark over there. Then I'm going to have a look at the information that I have. What information do I have? I have got the hypotenuse, right? I've got the diagonal, which is the side across from the 90-degree angle. Then I ask myself, right, from this point over here, I want the opposite, that's my question mark, and I have the hypotenuse. Okay, so opposite and hypotenuse. Now you need to think which trig ratio uses opposite and hypotenuse. Indiana, anybody know? Anybody know? Opposite and hypotenuse, that is sine, right? You guys probably can't type quick enough. So I'm
They're
going
probably
to say,
shouting it out there, Liesl. They're shouting it.
So sine and sine of what? I'm not going to write D, E, F. I'm now going to put the degrees in because I have the size of the angle. Sine of 20 degrees is equal to, right, I want the opposite, so that's y, and I have the hypotenuse, that is r. And actually I should possibly just fill it in, right? So let's put it in y over 58. Okay. Now the easiest way to make y the subject of the equation, because that's really what we want to do, because we want to solve for y, is to put the sine 20 over 1 and then do a trick called cross multiplication. So what I'm going to do is I'm going to say y times 1 is equal to sine 20 times 58, right? So 1y, or just y, is 58 sine 20. And then of course I'm just going to take out my calculator, clear it, and 58 sine 20. And the width of my hall is 19,8 meters. I'm going to round off to the nearest meter. So let's call it 20 meters. So I've calculated that this is 20 meters. Of course, guys, you must follow the instructions that your teacher gives you. 20 meters over there. Okay, so the question initially asked for both the width and the length of the hall. Now, because you know that this is 20 meters or roundabout, you could calculate the length of the unknown side, which is now the length, using Pythagoras. However, guys, I rounded off to get to 20. So what I try and do, if it's at all possible, is I try not to use anything that I have calculated myself, because I know that anything that I have calculated myself could have been rounded, and also, of course, there is the possibility that something that you calculated yourself could be incorrect. So what I'm going to do now when I calculate the length of the hall is I'm going to pretend that I never knew that the width of the hall was 20 meters, and I'm placing myself back over there and I'm saying, right, now I want, oh, I've moved my triangle, how cool is that? I want the length relative to where I'm standing is x. It is adjacent to me. I was given originally in the question the hypotenuse, and I'm going to say, right, adjacent over hypotenuse is then cos. So I'm going to now write cos of 20 is, that's 20 degrees, x over r, but I do know that r is 58. So what you see I'm doing now is I'm just using the information that they actually gave me. So I've got no possible chance that I'm going to use an incorrect value. I'm writing the cos 20 over 1. I'm going to use this trick called cross multiplication, top times bottom, top times bottom. In this case, it's easy enough. X is then 58 cos 20. And out comes my calculator, 58 cos 20, 58 cos 20, and the length of the hall is 54,5 meters. Okay, now if we have a look back at our original sketch, if I just scroll up a little bit, it actually makes perfect sense. That's 54.5. This is around about 20. The proportions seem right. Remember, guys, your hypotenuse, your r, is always your longest side. So if it's not, you might have made a mistake somewhere. Right, so this is the first question that's a little bit more practical. It's not hectically difficult, but I do have another one in store where you might have to think a little bit more carefully. Now we're going to take a break. After the break, we'll be talking about the next question.
Okay, fantastic, guys. So before we take that break, I just wanted to let you guys know, please get those questions in and please show me where you've gotten lost. I think that's the hardest, is when people say, I don't understand, sign, but where don't you understand? Let me know so it's easier for us to help you out. Guys, I've just posted a picture of Taiwan on the page. He is our new presenter. And guys, I'm not going anywhere, don't worry, so none of you need to panic. This is just another presenter, so it's double the trouble and double the fun. Okay, we're going to go to a quick break. When we get back, we'll be going through all of those burning questions you may have. Don't leave, we'll see you now. Hi guys, and welcome back. We're entering our last 15 minutes of the show. Can you believe it? It's amazing how time flies. So guys, get those questions in because the last 10 minutes are dedicated to questions. If we don't get any questions in, we'll be working through a question with you guys anyway, so keep stuck to those seats. I just loved Kashifa. She sent in top 5 excuses for not turning in math homework, and I thought maybe I should let Liesl know.
Please, I need to know this.
Just so her learners can't do the same thing. Okay, so number 1, I have a solar calculator and it was cloudy. Number 2, I had too much pi, pi, and got sick. Number 3, I could only get arbitrarily close to my textbook. Number 4, I accidentally divided 0 and my paper burst into flames. Number 5, it's Isaac Newton's birthday. So guys, those are your top 5 excuses for not turning in math homework. I'll share them on the page because they're pretty funny. Hopefully none of your teachers are watching. So Liesel, let's do this. Last 15 minutes, 10 minutes. Take it away.
Right, so guys, what I just want to say is once I've gone through the question, obviously I explain it quite slowly so that everybody can understand. But if you are able to calculate the solution, I want you guys to let Indiana know so we can give you a shout out on the page. Right. The question says, in the sketch below, BCDE is a rectangle. Now guys, the moment we refer to shapes such as a rectangle, you've got to think of the properties. So what do I know about a rectangle? I'm going to just highlight, not in black, I'm going to highlight it in my favorite color, which is pink. There is my rectangle. So you guys will get out your highlighters, you will highlight that rectangle, and you will say, well, what are the properties of a rectangle? Well, obviously, the angles are 90 degrees. But a very important property that we often forget about is that besides the fact the opposite sides are parallel to each other, that's a fact. Also, the opposite sides are equal in length. So, if side BC is 6 units, then I can automatically say that side DE will also be 6 units. Just for those of you that are working ahead, the question is to calculate the size of angle A. Okay, but we might have to do a bit of work before we get there. So I've said the very first thing that I noticed was that word rectangle, and I stopped right there. I took my highlighter, I highlighted the rectangle, and I said, right, I know stuff about a rectangle. Vertices, 90 degrees. Opposite sides are equal in length. So if BC is 6 units, then ED must also be 6 units. Right, so I'm putting that in straight away. The other thing that I know about a rectangle is that the opposite sides are parallel. So therefore, they are telling us over here that BDC, this angle over here, is 40 degrees. Guys, I also know then that that angle over there is 40 degrees. Why? I wonder if you guys will tell me why is this 40 and that 40, Indiana. We'll wait for the people on the page to talk about that. Right. Now the question says, determine the size of A rounded off to 1 decimal place. Now, before I jump in and just start calculating the value of A, I want to look at some of the other information as well. I was told that AD is 10 units. Now, I know that ED is 6 units because it's the opposite side from BC, and of course the opposite sides of a rectangle are equal. Do you guys then see that this side over here must be 4? Because the 6 and the 4 together are going to give me, the 6 and the 4 together are going to give me the 10. Okay, now in this question there is no way that I can directly calculate the size of angle A, and these sorts of questions very often come up. What happens is we give you a lot of information in one part of the diagram, but we actually ask the question in another part of the diagram, and what you then have to do is you have to figure out the connector. Now in this case I'm going to look at my connector as this side BE. That is the first thing that I'm going to try and calculate, is that side. Okay, so guys, perhaps you could have mentioned that angle DBE is equal to 40 degrees. It's the same as this one, Indiana. Anybody know yet?
No answers coming through yet.
Oh, we'll
send those answers through.
Send it through. It's a reason in geometry. Fine. So what I'm going to do now is I'm going to place myself over here at this 40-degree angle. Okay, if I make myself any uglier, it could get quite frightening. I think what I'm going to do actually is I'm going to just redraw the part of my diagram that I'm actually using at this point. So at this point, I'm going to be using this part of the diagram, 40 degrees, 6, and this side over here, which I call BE, I've highlighted there, that is the side that I want to calculate. So now I say, I am placed over here at the 40-degree angle. I have the side opposite me, across from me, so I have Y. I am looking for the side next to me, so I'm looking for X. Y and X, opposite and adjacent, that trig ratio is called tan. So I'm going to say tan of 40 equals, right, I am running out of space here, so let's do that below here. Tan of 40 is equal to 6, that's my opposite, and then my adjacent over X. Right. Now I need to find out what X is. I'm now going to use my cross multiplication trick again. If I multiply top times bottom and top times bottom, I now get X tan 40 is equal to 6. Obviously, guys, I want to isolate the X, so I'm going to divide both sides by tan 40, and I'm going to get that X is equal to 6 over tan 40. So, out comes the calculator. I've just quite simply changed the subject of the equation calculator. So, what did we say? 6 over tan 40. Right, fraction 6 divided by. Now, guys, remember I've got the angle, so now it's not shift tan. Shift tan is only if I want the angle, I don't have it. And tan of 40 degrees, and I did 44, so let's fix that, equals. And I get 7,15. So I'm going to go back to my diagram. Go away, calculator, 7,15. And I'm going to say right now, I know that that is 7,15 degrees. Now, if I now look at the top triangle, I'm now going to redraw my triangle just very quickly again. If I look at that top triangle, or maybe we're running out of space, so maybe I shouldn't. If I look at this triangle, I have got the opposite side, I have got the adjacent side. Oh, hang on a second, I want the size of angle A. So relative to A, opposite is 7,14, adjacent is 4, so the trig ratio that I'm going to use is tan. So I'm going to write that tan of A equals the opposite side, 7,15, divided by 4. Now guys, this time I'm looking for the angle, so now I'm using shift tan, and I'm going to quickly clear my calculator. Shift tan of 7.15 over 4, and that is going to give me, let's try that again, shift tan of 7.15 over 4, close my bracket, and that's 60,77 degrees. Guys, Indiana, I don't know, did anybody come up with alternate angles and 61 degrees, more or less?
Yes, we had a whole bunch of people coming back with alternate angles. Kashifa said the angle is 40 degrees because of the basic geometric rule of alternate angles.
Ooh, very
when two
nicely
lines
put.
are parallel. Yeah. So that's a good one. So guys, to all of you guys that did get the right answer in, well done. Kumiso got the right answer. Koketso, you got the right answer. Priska got the right answer. So guys, well done for that. And unfortunately, we've come to the end of the show. Keep helping each other out on the page. And grade 11s, don't forget that you guys have a surprise. Tawanda's taking the show, and I can't wait for you to meet him. Grade 10s, thank you for a fantastic show. See you same time, same place next week. Goodbye.